All right, we're going to pick up where we left off with making balanced punch. So here we have grape juice ounces on the x-axis or the horizontal axis and blueberry juice on the vertical or the y-axis. And we've seen that this is our line, this is our recipe for making blue punch, perfect blue punch. That's perfectly mixed, that's perfectly balanced. That's not too grapey and not too blueberry-y, but has the perfect mixture of both of them. And we see that if we have 3 ounces of grape juice, how many ounces of blueberry juice are we going to need to make a balanced punch? Well, the line tells us 2 ounces. If I have 6 ounces of grape juice, how many ounces of blueberry juice will I need to make just the perfect amount so it's not too blueberry, it's not too grapey, it's perfectly blue punch. And so if I have 6 ounces of grape juice, I'm going to have 4 ounces of blueberry juice to mix with it. All of the points that are on this line will make balanced blue punch, and there are an infinite number of pairings of blueberry juice to grape juice that we can have. All of these points in between, and all these points in between, and all these points in between, and we could go up forever to make increasingly larger numbers or larger batches of punch. As long as they're in the ratio, there's an infinite number of grape ounces to blueberry ounces that we could have. For instance, if we had 12 ounces of blueberry, then we would need 8 ounces, 12 ounces of grape, then we need 8 ounces of blueberry. So 12, 8 would also be a point that's on this line. And then 24, 16, way out here. Do you see a pattern that it's always going to be basically multiples of 3, 2? In this case, because it's a proportional line. So we can have there are an infinite number of pairings that will make perfectly balanced blue punch. Okay, there's not just one answer, there's an infinite number of answers. And so that's why in our equation that represents this line, we're not actually going to fill in our grape ounces and our blueberry ounces. By the way, the grape ounces are on the x-axis, so we'll call that x, and the blueberry juice is on the y-axis, so we'll call this the y. So we could even erase these and just call x and y. A relationship between x and y is y equals 2/3 times x. Let's try that out. For instance, here we have our x is 3. Here we have our x is 3. And if our x is 3, then our y needs to be 2. So let's plug in or replace or substitute in 2 for y and 3 for x. Okay, 2 times 3 is 6. 6 divided by 3 is 2. So do you see that 3, 2, when we insert it into this equation, balances the equation out? Because 2 equals 2. We balance the equation, just as we have balanced blue punch. Not too much grape, not too much blueberry. That's what it means to solve an equation. In this case, it means an xy pairing that balances the equation out. And only points that are on this line will have the property of balancing the equation out. For instance, we could do 6, 4. Let's put in 6 for x, or the grape, and 4 for the y. So 6 and 4. 2 times 6 is 12. 12 divided by 3 is 4. So 4 equals 4. Do you see it's balanced out? So all of the points, there's an infinite number of coordinates that are on this line, but all of them will balance this equation out. And that's what it means for a coordinate to solve an equation. All right? Now, we can come up with these equations given just 2 points. We don't actually have to have a graph. So let's say that we didn't have any of this. All we had was 3, 2 and 6, 4. And that's all the information we had. Given that information, we could come up with the equation y equals 2/3 x, even though we didn't have the graph for it and we couldn't see anything. So in the next video, we're going to come up with this equation given these 2 points, but nothing else.